In computing, multitasking is a concept of performing multiple tasks, also known as processes, over a certain period of time by executing them concurrently. New tasks start and interrupt already started ones before they have reached completion, instead of executing the tasks sequentially, so each started task needs to reach its end before a new one is started. As a result, a computer executes segments of multiple tasks in an interleaved manner, while the tasks share common processing resources such as central processing units, CPUs, and main memory. Multitasking does not necessarily mean that multiple tasks are executing at exactly the same time, simultaneously. In other words, multitasking does not imply parallel execution, but it does mean that more than one task can be part way through execution at the same time, and that more than one task is advancing over a given period of time. Even on multiprocessor or multi-core computers, which have multiple CPUs/cores, so more than one task can be executed at once, physically, one per CPU or core, multitasking allows many more tasks to be run than there are CPUs. In the case of a computer with a single CPU, only one task is said to be running at any point in time, meaning that the CPU is actively executing instructions for that task. Multitasking solves the problem by scheduling which task may be the one running at any given time, and when another waiting task gets a turn. The act of reassigning a CPU from one task to another one is called a context switch. The illusion of parallelism is achieved when context switches occur frequently enough. Operating systems may adopt one of many different scheduling strategies, which generally fall into the following categories. In multiprogramming systems, the running task keeps running until it performs an operation that requires waiting for an external event, for example reading from a disk or tape, receiving a message from a network, reading from a terminal or other human input device, or until the computer's scheduler forcibly swaps the running task out of the CPU. Multiprogramming systems are designed to maximize CPU usage. In time-sharing systems, the running task is required to relinquish the CPU, either voluntarily or by an external event such as a hardware interrupt. Time-sharing systems are designed to allow several programs to execute apparently simultaneously. In real-time systems, some waiting tasks are guaranteed to be given the CPU when an external event occurs. Real-time systems are designed to control mechanical devices such as industrial robots, which require timely processing. The term multitasking has become an international term, as the same word is used in many other languages such as German, Italian, Dutch, Danish and Norwegian.